nothing that I say.
Master, moving stones around is one thing. This is totally different.
No, no different. Only different in your mind. You must unlearn what you have learned.
All right, I'll give it a try.
No, try not. Do. Or do not. There is no try.
We've been playing this game since before the birth of this planet, and will continue to do so long after the death of yours. We don't cause the destruction of a world, Captain Carter. We simply manage it. Feed off it, if you like. But on every host planet, it always plays out exactly the same way. Populations rise, societies divide, wars spread. And all the while, the neglected planet slowly fades.
They'll come at you sideways. It's how they think. It's how they move. Sidle up and smile. Hit you where you're weak.
How are you doing this, Vincent? How have you done any of this? You want to know how I did it? This is how I did it, Anton. I never saved anything for the swim back.
Remember, the enemy has only images and illusions, behind which he hides his true motives. Destroy the image, and you will break the enemy.
I would rather have questions that can't be answered than answers that can't be questioned. Richard Feynman. Good afternoon. When I go on these long live streams, I tend to diverge from the original topic, and so what I'm trying to do is trying to follow up if there's something that I diverge into to talk about in a different video, a different live stream, and hopefully shorter. And so this one, it's I want to take a different approach to. It's not really flat Earth. I just want to focus on the globe Earth declarations, and you know, for me, flat Earth, I guess I am gonna say it. Flat Earth isn't about watching 100 hours of videos to become a flat earther. Nope. It's looking into the official narrative that is the globe Earth model. It's not about debunking the globe Earth model. Rather, it's about repeating the observations, scientific experiments, and mathematical formulas, and not coming up with a different result. If those cannot be done by you, you're just taking someone else's claim for the truth and without evidence to back it. So, in short, it's just a belief. Now, hopefully that's not the case. If you want to ensure that the globe Earth model is exactly what you're living on, well, you should do everything you can to repeat those scientific experiments, those observations, if they're not scientific experiments, and those mathematical formulas. It should be, hey, we live on a globe. Look, I will just present the same thing that we've been presenting since, what is it? 500 BC, 2,500 years ago or something like that. So let's move on to it. And here we go. Now, what I have here is my own document. Okay, you can write up your own document. You can come up with your own sources. It's like, hey, this is all I need to show people flat Earth, or actually, you know, to bring them back. Let's bring people back from flat Earth to the globe, and and I'm gonna show them. Here it is. I'm just gonna show them. I'm gonna do the exact things that people back then did. I mean, it's 2,500 years ago. It's no longer the Iron Age. This is the Information Age. We've got supercomputers. You know, our computers right here is way more advanced than what they were able to use. We got a lot more information that they had. So it should be easy, right? Now, I'm not just going to do this. I'm actually just also going to show you where I got everything. So first thing I do, I mean, I'm not going to use DuckDuckGo. I'm going to use Google. So who proved Earth was a globe? And you'll get a bunch of results. You can do Wikipedia, but you know what? Let's change it up. Let's use starchild.gsfc.nasa.gov. Let's see what NASA has to say. And Starchild question of the month for February 2003. Who figured out the Earth is round? Answer. Let's bring it up so you can see a lot better. And actually, it has actually been known that the Earth was round since the time of the ancient Greeks. I believe, why do I have to even say that? That it was Pythagoras. I mean, you believe or you know. But let's see, who's the person that's actually answering this? Phil Newman? Maybe? They don't really say. But because as I recall, he based his idea on the fact that he showed the moon must be round by observing the shape of the terminator, the line between a part of the moon in light and part of the moon in the dark as it moved through its orbital cycle. Pythagoras reasoned that if the moon was round, then the Earth must be round as well. After that, okay, so let's just stop there for a bit. Okay, so it's an observation. It's not really a experiment. So he observed, hey, if the moon is round, and back then, remember, you can't see the dark side of the moon, so it appears as a flat disk. You just have to assume that it is round, that the moon is round. But let's not even get to that part. Ooh, it's bright. We got this representing the sun. It's 1500 lumen light. Okay. Let's say this is the moon. This is just a picture of the moon. But, you know, we're going to run a little observation here. Oh, I need a better way of doing this. Okay, now we're going to have an object that's blocking part of the Earth. Okay? Or part of the moon. See that shadow that's cast onto the moon? Okay? I'm doing this live. That's a curved shadow. Now, is the object that's casting this curved shadow, is it round? It could be round. But you know what? This one, it's flat. It's just a flat circular disc. So, right there, we've come up with a different result. That's interesting, right? Yeah, it could be a round ball that casts that curved shadow, but it could be a circular disc. So, all right, that's when we could say the Earth is round, but it's not proof. It's just an observation with a different result that we just got. Okay, so let's move on to Anaxagoras. that's how I say his name right. After that, sometime between 500 BC and 430 BC, a fellow called Anaxagoras determined the true cause of solar and lunar eclipses. And then the shape of the Earth's shadow on the moon during a lunar eclipse was also used as evidence that the Earth was round. Again, the shape of the Earth's shadow on the moon. A shadow is a two-dimensional representation of an object, a three-dimensional object. Three-dimensional doesn't mean that it's, I mean, this is a three-dimensional object, but it's the shape of a circular flat disk. This doesn't, it doesn't prove that the shadow, the curved shadow, was that of a ball, because we can create that same curved shadow with the flat disk. So there are problems with these observations from Pythagoras and Anaxagoras. It's not bad. It's observation. Yes, it could be a ball, a round ball that's casting that curved shadow on the moon, but it could also be a flat disk. Now, let's move on. He goes, around 350 BC, the great Aristotle declared that the Earth was a sphere based on observations he made about which constellations you could see in the sky as you travel further and further away from the equator. And during the next 100 years or so, Aristarchus and Eratosthenes actually measured the size of the Earth, so we'll get to them later. So here, again, doesn't say experiment, scientific experiment, it says observations. So basically stating that as you move further along the plane of the Earth, you look up into the night sky because the constellations appear differently as you're moved away. It's therefore we know what's underneath this. We know what the shape of the Earth is by looking at to the night sky and walking around away from the, I assume, further away from the equator, not east to west, but north to south. Observations. I guess you could go and repeat it, but looking at the constellations, is that going to prove to you the shape of the Earth that you're walking on? Doesn't make sense. Doesn't, I don't know how you would come across that same conclusion. It's not definitive proof. Okay, now let's go to Aristarchus. Now, Aristarchus, if you do Google search, you'll see Aristarchus with Samos, Wikipedia, you got Britannica.com. So you know we could go ahead and look at Aristarchus. What I actually got this from is, I think it was Britannica. So if we look at the www.britannica.com, it shows, let's see, using premise 3, so he had, so Aristarchus' only extant work is on the sizes and distances of the sun and moon. The oldest surviving geometric treatment of this problem Aristarchus takes as premises that 1, as observed during a lunar eclipse, the diameter of the Earth's shadow is twice the diameter of the moon, so it's an observation. 2, the moon and the sun are 2 degrees in angular diameter, a measurement, observational measurement. And at the time of the quarter moon, the angular distance between the moon and the sun is 87 degrees. It's another observation and measurement. Using premise 3, Aristarchus showed that the sun is between 18 and 20 times farther away from the Earth than the moon is. 18, so what is it? Is it 18? Is it 19? Is it 20? I mean, that's quite a variable. It's not quite precise. The actual, and they say the actual ratio is about 390. I don't know how they got that. Anyways, using this result in premises 1 and 2 in a clever geometric construction based on the lunar eclipses, he obtained values for the sizes of the sun and moon. He found the moon's diameter to be between 0.32 and 6.40 times the diameter of Earth, and the Sun's diameter to be 6.3 and 7.2 times the diameter of Earth. So approximation is not exactly very accurate. And so if we go to the Wikipedia, it says he was an ancient Greek astronomer and mathematician. Look, yeah, the math, the formula is gonna be good, but is the actual output good? I mean, if you've got bad input, you're gonna have bad output. So let's see, who presented the first heliocentric model that placed the sun at the center of the known universe with the Earth revolving around it. Now, what I have to state is this little note that he measures the diameter, not the radius of the Earth, Moon, and Sun. So, and he's assuming that the Sun is 18 to 20 times further away from the Earth than the Moon is. So, it's observation, that scientific experiment, and all that stuff. And if he uses math, well, the geometry is correct, but the input that he proposes, is that the correct output? Okay, it seems like it's not 100%. I think most of the people who would state that the Earth is a globe would attribute it to Eratosthenes. And what's funny about Eratosthenes, when we look into the Wikipedia, says he's a Greek mathematician, geographer, poet, astronomer, and music theorist. He's a man of learning, becoming the chief librarian at the Library of Alexandria. He invented the discipline of geography, including the terminology known today. He is best known for being the first person to calculate the circumference of the Earth, which he did by comparing angles of the midday sun at two places a known north-south distance apart. His calculation was remarkably accurate. He was also the first to calculate the tilt of the Earth's axis, again with remarkable accuracy. Additionally, he may have accurately calculated the distance from the Earth to the Sun and invented the leap day. He created the first map of the world, incorporating parallels and meridians based on the available geographic knowledge of his era. He was also the founder of scientific chronology. Yada yada yada, you can read more about it. So let's go to the measurement of Earth's circumference. Now this is where it's fun. Alright. Wow, it just doesn't. Alright, that's fine. And this is where I pretty much copy here. And I'm highlighting some things that are in red here. Eratosthenes calculated the Earth's circumference without leaving Alexandria. Oh, shoot. I put it without leaving Egypt. I guess that changed. Without leaving Alexandria. That's different. Alright. So he never left Alexandria. He knew that local noon on the summer solstice in Syene, modern Aswan, Egypt, the sun was directly overhead. Syene is at latitude, etc., etc. Anyways, he knew this because the shadow of someone looking down a deep well at the time in Syene blocked the reflection of the sun on the water. He then measured the sun's angle of elevation at noon in Alexandria by using a vertical rod known as a gnomon and measuring the length of the shadow on the ground. Using the length of the rod and the length of the shadow as the legs of a triangle, he calculated the angle of the sun's rays. This turned out to be about 7 degrees or 1/50th the circumference of a circle. Taking the Earth as spherical, and we don't know why he took the Earth as spherical. That right there is an assumption. And knowing both the distance and direction of Syene, he concluded that the Earth's circumference was 50 times that distance. And again, if you keep reading, it says here, he made 5 important assumptions, none of which is perfectly accurate. I should go and probably copy that down, huh? That seems like an important piece. Now, when people talk about Eratosthenes, they're going, no, he proved that the Earth is a sphere. Well, here it says he made 5 important assumptions, none of which is perfectly accurate. I'm saying that the Earth is a perfect sphere. That was his assumption. And that's how he calculated the Earth's radius. Because he had to assume that the Earth is a perfect sphere. You know, you can forget about all the other stuff. Let's just say, hey, that assumption right there, the Earth is a perfect sphere. That is not proof. Again, actually, I have it here. Who proved Earth was round or a globe? You know, this one first result. Eratosthenes performed an experiment. Wait, is that correct? Did he perform an experiment? Is this an experiment? I mean, he never left Alexandria. He had to make assumptions. I don't think an experiment uses assumptions. So, I wouldn't. Maybe it is an experiment, but not a scientific experiment. I only think of one type of experiment. So that's like the first result, and it's the Wikipedia. So let me look. Independent.co. How the ancient Greeks proved Earth was round. So you proved Earth was round by assuming that the Earth was round. Can't make this stuff up. Like I'm not doing anything but going over the declarations of Earth is a globe. So Earth is a globe because we're assuming that Earth is a perfect sphere. It's funny. And I could stop there, but let's keep going. Isaac Newton. And let's see. Let's do a search for gravity. And that's going to come up with, of course, the Wikipedia. The Wikipedia will mention Newton's law of universal gravitation, which describes gravity as a force which causes any two bodies to be attracted to each other with a force proportional to the product of the masses and inversely proportional to the square of the distance between them. Pretty much what I put there. So it states that every particle attracts every other particle universe with a force. Keep that part handy with the force. First name Mike, hello. A selenelion is a better reason to question what is causing the shadow of the moon. A selenelion is when you see the sun and moon in the horizon during an eclipse, impossible Earth causing shadow. Again, what I'm actually going to do is just go over nothing else. I'm just going over the globe Earth declarations. What's been declared that the Earth is a globe? Going through history up to the present time with the different types of things. So we can go over any of the other stuff some other time. This one I'm trying to stick strictly to globe Earth declarations. June Desjardins. Sorry if I don't say your name correctly. Oh my, the book. A Funny Thing Happened on the Way to the Moon comes out in June. Could look into that later in June. Okay. So, he gives this mathematical formula where F is the force of attraction between the two bodies, G is the universal gravitational constant, M sub 1 is the mass of the first object, and let me see if I could find that equation here. Here we go. This is the equation right here. It's an image, so I had to write it down a different way. So this is the equation right here. If you guys see, it's highlighted in blue. Where F is the force of attraction between the two bodies, G is the universal gravitational constant, M sub 1 is the mass of the first object, M sub 2 is the mass of the second object, and R is the distance between the centers of each object. Now, again, they call this the Um, universal gravitational constant, G, that is important because you can have the masses between them and the radiuses, but it needs to be multiplied by G. What is the universal gravitational constant? So we're going to skip ahead. You know, there's another thing that happened in the late 1600s, which is going to support the Globe Earth Declaration, the Globe Earth model. But so we're going to skip it. And we're going 111 years later to Henry Cavendish in 1798 AD. So let's look at Henry. Let's do Let's just look up Henry Cavendish, because they'll probably go over the Cavendish experiment. Okay. Wikipedia. Was an English natural philosopher, scientist, and an important experimental and theoretical chemist and physicist. He is noted for his discovery of hydrogen, which he termed inflammable air. He described the density of inflammable air, which formed water on combustion, in a 1766 paper on factitious airs. Antoine Lavoisier later reproduced Cavendish's experiment and gave the element its name. So let's go to his experiment. Okay. Let's go ahead and go to that. Oh, shoot, I don't mean to do that. Let's open up in a tab. Okay, it was performed in 1797 to 1798 by British scientist Henry Cavendish. Was the first experiment to measure the force of gravity, again, Newton's force of gravity, between masses in the laboratory, and the first to yield accurate values for the gravitational constant. So pretty much I copy pasted that here. Okay. Because of the unit conventions then in use, the gravitational constant does not appear explicitly in Cavendish's work. So isn't that something just a little weird? Okay, but anyways, instead the result was originally expressed as the specific gravity of the Earth, or equivalently the mass of the Earth. His experiment gave the first accurate values for these geophysical constants. So you're gonna want to know, hey, so what was it? And it is this, right? Cavendish's value for the Earth's density gives. The G is the gravitational constant. You could do other stuff right here. That's pertinent. Alright. But basically, all I'm doing is copying that over here. But the uncertainty in parentheses, which is this. Which I got that from somewhere else. But again, it's going to give you... It's pretty much exactly the same, right? So his measurement 111 years later actually gives the universal gravitational constant, which supposedly proves the force between objects. Sounds a little weird. Wait, it took you 111 years to prove Newton's law of universal gravitation? That's questionable. It's like, well, they couldn't measure it at that time when he came up with it. Like, how did he prove his mathematical formula was correct? That it was universal and that it was constant and that it became a law? I think we may have to do a little bit more historical research to find out whether the law became Newton's gravitational universal gravitation, his formula, whether it became a law during or after his death or until Henry Cavendish measured it. It's like, let's just state it as a law, folks. Just seems weird. Okay, Albert Einstein. Oh, let's move back, because before Albert Einstein, along the same time as Isaac Newton, we have Blaise Pascal, Florent Perrier, and finally Otto van Guericke. So why are they important? Well, I'm asking, who proved the vacuum of space? Because it's pertinent to the globe Earth model that gravity is based on the mass of the Earth and the size of the Earth. But just what's outside, what's above our atmosphere. And right now, it's claimed that it's a vacuum. Space is vacuum. So it says here, a brief history of space. This is by physics.org. But if we go there, of course, here it is, physics.org. A brief history of space. As late as the 17th century, here, let's go ahead and make it easier to read. I'm just copying it. As late as the 17th century, it was assumed that space could not be empty. It was assumed. Maybe I should just go ahead and just copy and paste it rather than... Here we go. It was assumed could not be empty. Okay, another assumption. René Descartes argued that the entire universe must be filled. This was gradually shown to be wrong through work on air pressure by Blaise Pascal, Florent Perrier, and finally Otto von Guericke, who demonstrated that the density of the Earth's atmosphere decreases with increasing altitude. Scientific experiments could go in and find that, but concluded that there must be a vacuum between the Earth and the Moon. Right. Again, late 17th century, late 1600s. How do they conclude as proof that there is a vacuum between the Earth and the Moon? Where's the scientific experiment that was done? Is there a mathematical formula? Did they build rockets and spaceships to go in out past the Earth's atmosphere to test things out? Well, when did we finally get to outer space? As NASA or the Russians who went out there? It wasn't until mid 1900s, right? So they're just 250 plus years early. They concluded that it must be a vacuum. But why must it? How was it must? If that is even a term. Yeah, June Descartes, space is not the container. So let's move forward. Okay, so these are questionable. All these red things, like, hey, if I'm gonna defend the Globe Earth Declaration, the official narrative of the Globe Earth model, I need to clear up these assumptions and say, okay, we proved all these assumptions. But then you're gonna go, hey, who proved all these assumptions? NASA. Isn't it? And you're gonna find out that every one of these issues, all you have to do is say NASA proved what these people did in the past that is true, because NASA are the gatekeepers. And so that's just another thing. But of course, you're not going to be NASA. We're going to put NASA out of the equation, because this is just the declarations that were made before NASA. So Albert Einstein, we'll get into NASA later. I think that's a good one, because it's going to boil down to NASA. NASA. Sounds a lot like massa, right? Whew. It's bad. Ebon, shame on you. Okay. Albert Einstein, 1915 AD. Einstein's theory describes gravity as not a force, but as a consequence of the curvature of space-time caused by the uneven distribution of mass. And it gives out this, equation. Did I just make that up? But then no, this is part of the gravity, right? We're on Wikipedia on gravity, and we'll get to Einstein. Let's do describes gravity. All right, here we go. It's pretty much up at the top. Gravity is most accurately described by the general theory of relativity posed by Albert Einstein in 1915, which describes gravity not as a force but as a consequence of the curvature of space-time caused by the uneven distribution of mass. So that's exactly what I put. And then I went ahead and found his field equation. I can't find it here, but you can find it. Don't take my word for it. Go and find his field equation yourself, which shows you the universal gravitational constant. He uses that as his theory, his equation. All right, so pretty sure gravity does not end there, but related to it is, well, part of gravity has to do with, well, how do we know what's within the Earth so we know that we can calculate it somehow as a solid or liquid or whatever, just find out the mass. And so you would type in who proved Earth's inner core. You'll come up with Inge Lehmann, I don't know if I'm saying it right. Discovery. Of course, inner core, Wikipedia, inner core, right? Wikipedia says the Earth's inner core is the Earth's innermost part. It is primarily a solid ball with a radius of about 760 miles, which is about 70% of the moon's radius. It is composed of an iron-nickel alloy and some other elements. The temperature at the inner core surface is approximately 9806 degrees Fahrenheit, which is about the temperature of the surface of the sun. 10 minutes. So here's the discovery, and this is pretty much exactly that I copy pasted out of this wiki. So the Earth was discovered to have a solid inner core distinct from its molten outer core in 1936 by the Danish seismologist Inge Lehmann, who deduced its presence by studying seismograms from earthquakes in New Zealand. She observed, that's another one. Yeah, so she deduced its presence, and she observed that the seismic waves. So there's no scientific experiment provided. It's deduction and observation. This boundary is known as the Bullen discontinuity, or sometimes as the Lehmann discontinuity. A few years later, in 1940, it was hypothesized, another interesting word here, not experimented, that this inner core was made of solid iron. Its rigidity was confirmed in 1971. Really? How was it confirmed? That's something else to look into again. Yeah, June Desjardins, no way to know. The deepest they ever dug was 8 miles. Multi-tom-tom. The lunar eclipse is an internal process, in my opinion. We're not going to go for the opinions. We're just going over the flat Earth, or globe Earth declarations. Oh, can you give that to me? Thank you. Okay. Now, finishing off, the outer core was determined to be molten from observations showing that compressional waves pass through it, but elastic shear waves do not, or do so only very weakly. The solidity of the inner core has been difficult to establish because the elastic shear waves that are expected to pass through a solid mass are very weak and difficult for seismographs on the Earth's surface to detect, since they become so attenuated on their way from the inner core to the surface by the passage through the liquid outer core. Dzwonski and Gilbert established that measurements, ooh, that's another key word, measurements, not experiments, but measurements, of normal modes of vibration of Earth caused by large earthquakes were consistent with a liquid outer core. Some measurements were consistent with the liquid outer core. There's just a lot of things to look into. So, in 2005, shear waves were detected passing through the inner core. These claims were initially controversial, but are now gaining acceptance. And again, claims. So, as a person who supports the globe Earth model, if that is you, and the official narrative that is presented, you're going to write up something similar to this. Because these are things that you're going to need to look into. And again, do they say scientific experiments? And let's look at when was the scientific method first introduced? Who invented the scientific method? To Europe as the Renaissance began, and the wisdom of the Greeks and Arabs helped Europe out of the Dark Ages. Roger Bacon, 1214 and 1284, is credited as the first scholar to promote inductive reasoning as part of the scientific method. But that's just the inductive reasoning part. The work of... wait a second, what? Oh, Francis Bacon was first to formalize the concept of a true scientific method, but he didn't do so in a vacuum. The work of Nicholas Copernicus and Galileo Galilei influenced Bacon tremendously. Let's look at that history of the scientific method. Let's see. Let's see. Okay. So let's just attribute that. Let's just say that that's the earliest. Okay. We'll go and put that into 1561. So 1561. Actually, we would call it 1621. So this is something to note. That everything before Francis Bacon was not considered... Everything before Francis Bacon was not... could not be something that was attributed to a scientific method. So all of this that's before Francis Bacon, before 1621 AD, had to have been more of observations and tests of observations. Okay. And those stayed here. These are assumptions, especially Eratosthenes. He made 5 important assumptions. They say that straight up, and that the Earth is a sphere. So he had to assume that Earth is a sphere to prove that Earth was a sphere in order to calculate a circumference, because you can't calculate a circumference without it being a sphere. Do you get that? That's why when you hear Nathan Oakley go on and on and on about presupposition and entire people who are there talking about that, that's important. But so these are the Earth is globe. This is the declarations of the globe Earth model. There are just a lot of things in red that have to be addressed, because these are the holes within the globe Earth model. And this is being honest. This is the results of Google searches, not DuckDuckGo searches. These are the results of Wikipedia's, NASA, science.howstuffworks.com, physics.org, Britannica.com. Okay, these are mainstream sources. These are the top 3, if not the top search result that Google provides, and I'm finding the information here. I'm not going to some conspiracy theorist website, some flat earth website. I'm not going to YouTube videos. These are exactly where I would expect normal people to find, everyday people, the majority of people who want to look up the globe Earth model. This is where you find it. And now, if you're going to be honest and say, okay, we gotta look at these in a very you don't even have to look at it as a skeptical way. You're just looking at, hey, I want to repeat these observations and deductions and assumptions. How would I do that? Well, first let's see if we can repeat the observations. Okay, again, starting with Pythagoras, because that's as early as it goes. And I showed you earlier, if you had one light source, and I know this isn't perfect because there's multiple light sources, but this is really bright and it's close, so you're going to see a shadow. This is a picture of the moon. Okay, and we're going to cast a shadow. Is that shadow on the moon that's cast curved? I mean, it looks definitely like it could be a globe, right? A round ball. But you know what? This is just a circular flat disk. So they're attributing proof that the Earth was a globe, starting at Pythagoras, even though it's not a proof from that observation, because I just showed you right then and there, me, someone in a basement dweller, high school diploma, dumbest guy in the room. I figured it out. I repeated that observation. I can conclusively say it's not a globe. I can't conclusively say it is a flat disk either, but it can be either. Okay, so but stating one over the other 50%, that is not proof. That is not direct evidence. So we have to rule out these two. And then we also have to rule out Aristotle because of observations where constellations change, right? So if people want, hi Nathan Oakley, awesome to see you. I was just listening everywhere. I mean, there's no nonstop talking about flat Earth stuff, but I just like to present it as globe Earth declarations, and that's it. These are the declarations made to support the official narrative of the globe Earth model. All found through Google searches. Top 3 search results, majority of them being Wikipedia. Going to Britannica.com as well. Physics.org as well. And science.howstuffworks.com. Not going also, let's see, starchild.gsfc.nasa.gov. I'm not going to YouTube videos. I'm not going to flat earth websites. I'm not going to anything else. Just these are flat earth declarations. These are it. Copy pasted. I highlighted things in red that just seems a little bit sketchy. And these are things that we would have to look more into to say definitively, because it seems to be every source that I'm looking for, they're stating it as fact. And so that's where I like to start off. I think these are things that I like to memorize. You know, when I go into your Nathan Oakley's Flat Earth debates and a globe earther comes in, I just want them to state what the globe earth model is, their declaration, and start from there. And if they don't know what it is, then I just right, just I don't know why they're even there to debate if they don't even know what their own model, how their own model is stated. And again, this is not including NASA. NASA is an entirely different subject. These are basically the origins of where the where we consider declarations that Earth is a globe. You know, where did it all start? How was it formed? And why do we keep referring to them as proof that Earth was a globe way before NASA? So that's it. 52 minutes. Man, I try to make these videos as short as possible, yet it keeps going longer than I think it is going to be. Nathan Oakley, I hope I'm going to make it to tomorrow's Flat Earth debate. We'll see. This was a weird week. Family, my son was sick, so can't really participate with a sick 1.5-year-old slash, he's almost 2 actually. So, all right, thank you everyone for joining me who joined, and for Globe Earthers, this is something that you should use. This is what supports your I hate to say it, this is what supports the concept that you live on a globe Earth. So thank you, Nathan. That is awesome. I would share your work, but not many people watch my stuff. But I always say, go to Nathan Oakley if you really want to break this down scientifically. Nathan Oakley is the person that I would recommend for looking at this all from the actual scientific method that is assumed that the globe Earth is presented. So, okay, thank you for joining me, and I'll see you all later. Thank you.